So welcome everyone to today's webinar and Swegon Air Academy. Swegon Air Academy is an objective knowledge sharing platform where we display case studies, we do webinars like this, and we share also articles and insights about HVAC, sustainability in HVAC, IQ, and system designs on our webpage. And we also publish books on the topics. So if you are interested in attending more webinars, sign up for our newsletter at Swegon Air Academy website. But today's webinar is about a case study where the property owner had high ambitions in building a sustainable and energy efficient smart building that also should be an attractive workplace for the tenants. And we will learn in this webinar how the supplier and the consultant together with the property owner have been working really close to create such a solution. And we will also learn how new technology has helped fine-tuning and ensuring that the property owner really got the solution he wanted from the start. So to discuss today's topic, we have a group of very experienced persons within the HVAC field. So we will cover everything from the project design phase to the operating and fine-tuning phase. We have Ulf Hörman, who works as a business development of Swegon system and solution at the supplier part. We have Erik Jansson, who is the consultant for building energy and HVAC at a Swedish consultancy bureau in the south of Sweden, erelko AB. Welcome. And we also have some experienced co-workers within the practice field. Anders Hultman, project system engineer at Swegon, and Robin Svensson, a service engineer at Swegon. And my name is Åsa, and I will moderate this webinar from the Swegon Air Academy. So now that you have been introduced, let's dive into the case. So we cover all the parts in this hour. I will hand over the word to Ulf Hörman, who will tell us a little bit more about this project.
Thank you very much, Åsa. Yes, so I want to start by telling you that this project has given us a lot of experience, and it still is. And I hope that you, after this seminar, will also learn a little bit more, have a better understanding about the importance of monitoring an HVAC system, especially as in this case, when it's a demand-controlled HVAC system. I'm convinced that all buildings in the future will be both demand-controlled and monitored. And we also see that legislation is going in that direction. Another interesting thing that I think that you should take with you after this seminar is the benefits, but also the challenges of designing a two-pipe changeover system.
So if we summarize this into an agenda, Ulf, what will we go through?
Well, we will start with a short introduction of how this project started. We will then go through the building design, both the original design, but maybe more importantly, the final design, since we did some relevant changes. We will look at the energy use that we calculated in the design phase, the energy use that we had in the declaration after the building was taken into use, but also the actual data, since we are measuring the building continuously. And in the end of the presentation, we will talk a little bit about the importance of digitalization, the findings that we have done in this building, and also finalize with some conclusions.
Great. And after the conclusion, we will also open up the chat. It's already open, so you can place questions there, and we will put them to our experts here for you to answer at the end of the webinar. So as we can't take the Blue House into our studio, we will start with a short film to take you to the site. Ulf, can you tell us a little bit more about the background of this project and how did you as a HVAC supplier get involved in this project?
Absolutely. So this building owner was a building owner that we had worked with a lot before, but not to the full extent as we have done in this project. He had built a couple of office buildings before, but he wanted this one to be more future-proof building and much better indoor environmental quality. So it should be future-proof, as I said, energy efficient, sustainable materials, and indoor environmental quality.
Yeah.
And to minimize the risk of not meeting the targets, he wanted to have as few suppliers as possible, taking a bigger overall responsibility. And that is when we came into the picture.
Okay, good. So a question to you both, Ulf and Erik, and maybe most to Erik as a consultant here. How important would you say it is that you are involved very early in the project and partner up?
Yeah, I would say it's very important. You have to involve suppliers early in the design process, and particularly when the systems incorporate novel or cutting-edge technologies, then it's extra important, I would say. Of course, suppliers have the expertise in their products, so you have to use that in the design process, and they can help designing the system in an efficient way.
Because it's hard for you to keep track of all the different products.
Yes,
features.
Of course.
Okay.
There's a lot of suppliers, so yeah.
And Ulf, what do you say as a supplier?
Yeah, I totally agree. To be able to make a good result, we need to be early involved in the project. Then we can influence the design, we can help selecting the right products and the right functionality to get the best possible performance of the building.
Good. Good comments and good thoughts. And let's keep those with us throughout the case that we will go through. And we will revisit these themes now and then throughout this presentation. And as we can see in the picture here in the presentation, that the building owner had a lot of focus in building a green and energy efficient building. But from the start then, Erik, as a consultant, your role to look at the energy and so on. Could you take us through that a bit?
Yeah, sure. Let's start by looking at the building envelope. And you can see in the picture here to the left, we have the blue house. And the blue house is constructed by insulated, pretty thick concrete walls. And we have fairly small windows. So that, of course, reduces the heat loss. And to handle solar heat gains in the summer, we have internal shading. And we also have, as we showed in the movie, PVC system on the roof.
Good.
Yeah. So if we take a look at this table here, we can see the different constructions and the U value. So, for example, we have walls at 0.17 watts per square meter and Kelvin. And I would say that's a pretty standard basic wall. And if we take a look at the roof, 0.1, that's, I would say, pretty standard value for, at least in Sweden, corresponding to maybe 400 to 500 millimeters of mineral wool or something similar. As you can see, also windows and glass sections has a U value between 0.8 and 0.9. And I would say that's considered pretty good performance to today's standards. And to put this in a little bit perspective, we can compare the mean U value for the building. So that's a total overall U value, which is 0.25 for this case. And if we compare to the national requirements, we had at the design a requirement of below 0.6. Today that is revised to below 0.5. So to sum up, it's twice as good as the national requirement. So pretty well insulated building. And also I would say that at least in Sweden, we have focused a lot historically on having well insulated buildings. So there's been a focus on that. And if you study these kinds of building from an energy perspective, you often see that you have to increase the insulation a lot to get significant heat heat gains or energy performance increases.
So it will cost a lot? Or?
Yeah, it will cost a lot and affect the construction a lot. So what we see is that we have to focus more and more on the HVAC systems and do things in the systems and try to make them as effective as possible. And that will, in many cases, reduce the energy consumption more than increasing insulation. So focusing on HVAC is important. For example, it's important to implement, for example, demand control ventilation or otherwise like VAV systems, some sort of VAV system. And another example is when designing heat pumps and chillers, you have to use correct design conditions to make it as efficient as possible.
So thanks, Erik, for that intro. And so if we summarize that, the first thing is that you need to have this well-insulated building, of course. But then you also have to design a sufficient system that is also saving a lot of energy, because that is a more cost balance than insulate more on the building shell.
Yes, I would say so, yeah.
Okay, so Ulf, if we go to the technical design of this building, I understood from what we have talked about before about this case that you had original design, but then the final design changed rather much when you came early into the project. You could influence a lot.
True.
Can you take us through the HVAC design?
Absolutely. So the original plan was already from the beginning to use climate beams for ventilation, cooling, and for heating. And that means no radiators. Instead, well, you have to have radiators where we don't have any ventilation or when we only have extract ventilation. But otherwise, it will be the climate beams. And then it was designed to have a chiller and a heat pump. But then we changed that to a reversible heat pump instead, taking care of both the cooling and the heating. And by doing that, we have to go from a 4-pipe system to a 2-pipe changeover system.
Okay, so a 2-pipe system, that is quite unusual in the Nordics, at least. And could you have some downsides in spring and autumn? How did you take care of that?
Yeah, that's true. So to manage the need of simultaneously heating and cooling, we had to oversize some of the climate beams. So the climate beams in the conference rooms, we oversized, both, of course, to take care of the air quality in the room, since it's a conference room with a lot of people, but also to be able to use free cooling in these rooms while the rest of the building needed heating.
Yeah, I think we have a short clip from the Blue House where you and I visited this conference room. So let's have a look and explain this a little bit more in detail, since the technology used maybe is not so common in some parts of Europe. We are standing in one of the conference rooms at the Blue House, our reference case. And Ulf, as we can see in the ceiling here, we have 4 quite large comfort modules installed in this room. And how come they are so much larger than the cell office comfort modules that are 600 by 600?
Well, they are oversized so that we can use free cooling with air when the rest of the building is actually needing heating.
Is that something special that we had to think about when designing the system, since it is a changeover system in this building?
That's true. That's the reason. So the chiller and the heat pump can only produce either cheap cold water or warm water. And when you produce warm water, and we still need heating here or cooling here because it's a conference room full of people, we can use the air to cool down this room while we heat up the rest of the rooms.
So it's very important to design the system in a correct way to give everyone the climate they want on this floor.
Exactly. Even if we were working with a 2-pipe system, yes.
Good. So Ulf, can you tell us a little bit more about the the design of these chill beams and the temperatures on the water side.
Yes, that's true. We also suggested to use water temperatures that was based on the demand. By doing that, we will get a much better performance of the reversible heat pump. But of course, by doing that, we will also need to design all the components to be able to match the lower water temperatures.
So let's take us through the schematics and have a look at the system, how it is built up.
Yeah, let's do that. So if we start from the room level, we heat, we cool, and we ventilate with the climate beams. And in some areas, we need to use radiators where we don't have any ventilation. And all the rooms where we have these products, they are active, so they control the indoor climate at all times. And they have built-in sensors, or they have sensors that is mounted on the wall. And we are controlling all the rooms with occupancy and temperature. And then some of the rooms we control also by air quality with a VOC sensor and relative humidity. The communication in this room management system is wireless all over the system. And then we have Ethernet cable between the products that communicates through Modbus. The ventilation is controlled by occupancy and demand. So the air handling unit pressure is controlled and optimizes the available pressure to be as low as possible at all time in the building. And also the heating and cooling, as you can see in the top right, it's produced by the reversible heat pump and the two-pipe changeover system. Heating and cooling is also demand control, as I said before. So all the valve positions in the system, they are monitored, and we optimize the water temperature at all time. And of course, all products are connected to our cloud service, so we can use that for monitoring, analyzing, and troubleshooting.
Okay, interesting. Then let's dive a little bit further into the different parts and start with these oversized radiators.
Yeah, exactly. So since this room management system controls almost all heating, cooling, and ventilation, we also suggested that we should take control over the remaining radiators. And by doing that, we would be able to control so that we don't heat and cool at the same time, which is of course not beneficial. But as I said in the previous slide, we then need to look at the water temperatures as well. So as you can see on the picture, we had to oversize the radiators quite much.
So you can use the same temperature.
The same temperature, exactly. Lower water temperatures for the radiators. Yeah, true.
Good. And I guess also inside the air handling unit, you also had some special selection.
Yes, true. So we changed from a normal condensation rotor to a sorption rotor. And by doing that, we could reduce the size of the reversible heat pump with a lot. So we could go down in size. And by that, we didn't only save money, we also saved the environment, of course, because we have a lower carbon footprint, less refrigerants, which is great.
That's great.
And sorption rotor is also beneficial during wintertime because we then take the moist from the building and get it back into the building again. And by that, we are improving the IEQ wintertime when you otherwise get dry indoors.
Yeah, in Scandinavia, the humidity drops to almost 15% inside.
Exactly.
In the wintertime. So I guess this will do a lot for...
That will help a lot, absolutely.
Yeah. Okay, but if we look at this from a technical point of view, what is actually happening here?
Yeah, so if you can see in the picture, if you have the same outdoor conditions by using a sorption rotor that returns most of the moist, wintertime it takes it into the building, summertime it takes it directly out before getting into the building. So removing a lot of relative humidity from the outside air directly into the exhaust air. And by doing that, we can reduce the cooling power needed significantly in the building. And also, we will reduce the relative humidity inside the building. So we will take down the risk of getting condensation indoors as well. So it's beneficial in many ways.
Very good. So should we just sum up the total design and how it ended up?
Absolutely. Short recap. So we had the sorption rotor that we changed, of course, and then we went from a 4-pipe hydraulic system to a 2-pipe changeover. And by that also we changed to a reversible heat pump. We are working with demand-controlled water temperatures, and we will talk more about that later because it's super interesting. And also we had to then oversize some products to match those temperatures.
So quite a lot of impact coming into the project early.
Yeah, I would say so.
Yeah, lots of changes. But as I have understood, it was not only the design that changed in this project, it was also some building regulations on country level in Sweden that changed, Erik. And how did that impact the project?
Yes, well, during the project, we could see that the building regulations was revised in Sweden. So a new version was introduced called the BBR 29. And for this project, it only affected the energy performance certificate, which is conducted after the building is taken into use. And you can see also that the energy performance, we have different energy classes. And with the new BBR, it became more difficult to reach those levels. So if we compare, for example, the requirement for energy performance between the old version and the new version, we can see that it was reduced down to 70 kilowatt hours per square meter from 80. So that's a stricter requirement. And the energy performance, when you calculate that number, you have to take the bought energy or delivered energy to the building, and you have to multiply it by a weighting factor. And those weighting factors were also adjusted. So as you can see in the picture, electricity went from 1.6 to 1.8.
Yeah.
And the blue house is only driven by electricity for heating and cooling and so on. So it becomes more difficult to achieve these energy classes, so to speak. And if you combine those two changes, the energy performance and the weighting factors, you can see that you have to decrease the bought energy at least 20% to keep the same energy performance as before. So
that's quite a challenge.
Yeah, of course, that's a challenge. So let's look at the actual performance for the building. First, we had the design phase where we made an energy calculation of the building. And we ended up in B class, and that was the aim of the project, to try to reach B class. The bought energy was 32 kilowatt hours per square meter a year. And the next picture shows when the building was occupied. After a while, we made an energy performance certificate. And this was with the new stricter regulations, BBR 29. And then with the same bought energy, we ended up in C class. So that was not something that we...
Disappointing.
Yeah, it was a little bit disappointing. Yeah, of course. So I will also say that the energy performance certificate in this case was based on calculated data because there was insufficient meter data available to perform a measurement-based assessment.
Okay.
Yeah. And if we take the next, it's if we look at the measured energy use, we can see from what the indications now tell us is that from last year's data, we are now ending up in B class once again at 25 kilowatt hours, somewhere around that.
In the
figure.
stricter regulations as
Yeah,
well.
that's BBR 29, so it's stricter. So
how should the property owner and the investor in this building think? Should he or she make a new EPC?
Yeah, I would say so, because if the property owner can show that the building has better performance than C class, which is national requirement, C class, then it can be qualified for lower mortgage rates, so-called green or sustainable mortgage. And also with a higher energy efficiency rating, you can increase the property value and potentially allowing for larger investments. So
then they can invest again more.
Yeah.
Any more values then with having a better EPC class?
Well, of course, if you have a better energy performance, the possibility to attract and retain tenants who prioritize sustainability and low energy use will become better. And this will result in a better offer and you can increase rental income, so to speak. And also, if you have, like in this case, you have tenants, if they work at a large company, they will have to report their energy use to the ESG system. So then they will use this data from this EPC.
So if we summarize, it's important to both get a good EPC classification and also to be able to report energy consumption and offering energy data to the tenants if you have, like in this case, an office hotel or
Yes,
absolutely.
Good. That was very clarifying. Thank you for that, Erik. And we will now switch topic a little bit, switch back to the property owner's vision about making a sustainable building. And if we focus on the CO2 emissions or the equivalents, how the system design impacts both the embodied carbon and also the operational carbon. So Ulf, I know that you have made a study in this reference case about this and can tell us a little bit more about both the embodied and the operational part.
Absolutely. So as you say, there is an increased focus on CO2 levels or CO2 emissions now, and it's getting worse and worse, or better and better. So we're looking at both the embodied carbon, which comes from the building, the envelope, and all the installations, but also from the operational carbon, from the energy use from the building. And in this specific case, since we have removed the radiators, we are heating with the climate beams, and therefore we have no radiators in the system. We have taken away 5,000 kilograms of carbon dioxide equivalents emissions.
That's a lot.
That's a lot.
Yeah.
And also by going from a 4-pipe system to a 2-pipe system, the changeover system, we are reducing an additional 800 kilograms of CO2 emissions. So all in all, I think that we have around 3 kilograms per square meter of reduced CO2 on the embodied carbon only.
Yeah, that's fantastic.
Yeah, super.
And if we look to the operational carbon?
Exactly. So in our system, in the room management system, we have standardized optimization functions, both on the plant level and on the room level. And we are optimizing both the air side with the duct pressure and the water side with the water temperatures. So at plant levels, we monitor all the valve positions for all the cooling and heating coils. And we adjust the water temperature to keep at least one valve as open as possible. And when all the valves are closing, we send a new set value to the reversible heat pump. And this goes also for the room products in the building. We do exactly the same thing. We are looking at the overall cooling or heating need in each room, and we take the average temperature that is needed, and we send that information up to the reversible heat pump.
So both optimizing on plant and room level.
Both on plant and room level. And the part of the system that has the highest demand sets the water temperature for the reversible heat pump to produce. So it could either be the air handling unit that needs more, or it can be the room management system that needs more. And then the room management system also optimizes the ventilation rates in all rooms based on demand. And we have the same principle there. So we're looking at the damper positions. So when all the dampers in the system are closing, we send a lower set temperature to the air handling unit for the pressure. And vice versa, when one damper goes above 90%, we send a new increased set temperature to the air handling unit. And this saves a lot of energy. So in this particular case, the SFP value for this air handling unit is 1.1 kilowatts per cubic meter per second, which is a really low value.
Okay, so Erik, then I have to ask you, in your original energy calculation, you had a COP-ER between 3.5. And compared to the measured data we saw, were you a bit modest when you did your energy performance calculation?
Well, we can see that we have a margin of safety in those assumptions. And during the project planning, we based our assumptions on supplier data for COP and EER. And I would say that the performance data was based on design conditions, which were harsher, and also design weather data. So more difficult to achieve a good COP and EER. And also we didn't include all the optimizations that was eventually included. So
yeah, but don't you need how should we achieve this zero emission building vision that we have for Europe and the new EPBD? How don't you need more realistic values from the start then, or?
Yes, of course, there will be a greater need for more accurate input data for calculations. And the margins for error are decreasing, of course, when you have stricter energy performance requirements. So, but I believe that both suppliers and the energy assessors need to improve the accuracy for both products and the calculations done from consultant level. And that's especially important when the systems are complex and when the products are very specific. So, yeah.
Okay. So, Ulf, how are you as a HVAC supplier going to match this?
Yeah, as you say, it's a tricky question.
Yeah.
We are looking at this, and we have to improve for sure. We need to be able to provide better data, more accurate data on what kind of energy performance we can supply. But when you combine it into a system, it gets a little bit more advanced than if you're only working with a product. But we are working on it.
So tighter collaboration.
Yeah,
I think so, yes.
So, but let's go back a little bit and look at these optimizing functionalities and how to optimize both the comfort and energy savings on the water side.
Yeah. So, I mean, the importance here, and this is where we save the energy, for every degree of higher water temperature that we need to produce in cooling mode, we save 3% of energy. And for every degree of lower water temperature that we need to produce in heating mode, we save 2.5%. So in this particular building, by working with demand-controlled water temperatures instead of outdoor compensated temperatures, we save approximately 20% energy during the winter time. And also, if you look at the graphs, for each month, you have the average temperature that has been produced. And as you can see, instead of working with the design temperatures of 40 to 45 degrees in heating, we are working with 28 to 33. And the same goes for cooling. So instead of 7-12, we are working with 12 to 17. And this is where we save a lot of energy.
Yeah. So a huge opportunity in savings on the water side. That's maybe a more hidden system part than we normally look at in the HVAC system. Well, if we then turn to the more traditional part with the air side, can we still do something there to?
Yeah, absolutely. I mean, this picture, it shows the pressure optimization in this building. So if you look at the red curve, it's the extract air duct, and the yellow curve is the supply air. And what you can clearly see here is that when people come to work in the morning, the pressure needs to go up because the ventilation rates need to go up. But then during the day, it varies. People are coming and going, but we are always keeping as low possible pressure as needed. So we save the fan energy, but also CO2 emissions, of course.
Great. And if we look at how these parameters and the fine-tuning of this optimization functions affects the indoor climate and how people feel and thrive inside.
Yeah, exactly. Because if you remember, the building owner wanted to have the best possible indoor environmental quality. So we need to monitor that as well. And we have. And we can see that in over 95% of the time, we are within temperature limits in all the rooms in the building. And the VOC level or the air quality is fair or better at 97% of all time in the building. So this that I show here is print screens from the room management system, where we can see one floor of the building. In the top floor, we see the temperatures, and in the bottom floor, we see the occupancy or non-occupancy. So I would definitely say that we are meeting the demands when it comes to the indoor environmental quality.
And this is from a very HVAC perspective, of course, that we are looking at this. But if we look inside the building,
looks quite nice.
It looks like a very nice building to be in. And a lot of effort, as you have seen here, has been made to create comfortable indoor environment, of course. So what would you say is the value of a good indoor environment, the quality, not only the good HVAC system that you have displayed here, but also acoustic, design, lights, all this coming together?
I mean, for the tenant, it's obvious. because it's his working place or her working place, but also for the building owner, I would say, because in this case, for instance, he uses part of the building to rent it out as a hotel office or office hotel, I don't know what it's called. And there, of course, he wants to have full occupancy and he wants to have the tenants staying there for a long time, which is the case as well, since it's a very nice environment to be in.
Great. Okay, so to ensure that there is a good indoor environmental quality in this building and a good comfort, we have some help. And the digitalization part is a big factor in this.
Yes.
So could you take us a little bit through what kind of digitalization tools are installed in this project?
Absolutely. So I want to start by saying that if you look at the new EPBD recast, there is a much higher, or there will be a much higher demand on the building owners to monitor the building in the future, to analyze it, and to also provide performance data. So this is super important in the near future, I would say. But for us, we are already here. So we have VPN tunnels to all the installed products. So we have direct access to their web pages, built-in web pages, both for the air handling unit, for the room management system, and also for the reversible heat pump. So we can monitor the performance at all time. We can see the IEQ, and we can make set point changes if you want in all the different products.
And you can also show and display for the tenants how the climate is inside.
Yes, that's true. We have a tablet in each floor where you can see the actual temperature in all the rooms in the building.
Anything else about?
Well, we have a cloud portal where we get the alarms from. So as soon as there is an alarm, it will be sent out to the user through text message or by email. We have 3 types of alarms. We have the A alarm, B alarm, and notification. An A alarm is serious, and that needs to be acted upon immediately. And that could be that the reversible heat pump has stopped, for instance. A B alarm, then you need to act as soon as possible, but it's not urgent. So that can be, for instance, that you need to change a battery in a product, or that your service period is overdue. And then the notification is more of an information. So it can be that a room has been outside the temperature limits for a certain amount of time and then goes back again, then the notification goes away.
And then if you want to analyze the system.
Yeah, I think this is the most important feature, I would say, when it comes to the findings later on. So we also have the possibility to take data points from all the different product groups in the system. So we can take data points from the air handling unit and from the reversible heat pump and also the room management system and put them in the same graph. And by that, we can look at what is happening all the time. So we can analyze, we can troubleshoot, we can, make all the best, we can trim the performance, so everything. And this is really important and a really good feature as well.
Great. Thank you for that overview. We will now welcome our system engineers, Anders and Robin, on the stage. And talk a little bit about what has it meant, the digitalization part and so on for you in your work. And you have worked with this system from commissioning until today. But first, describe your professional roles, what you work with in your daily business.
Yes, thank you, Åsa. I work mostly with support, calculation and construction with Swegon's components in HVAC system.
And I work as a technician, mostly with our air handling unit scope and DCV system supervise.
Okay, great. So all of these fancy digital tools that Ulf has shown now, it looks great, of course. And what about in practice then? What has the access to all the data meant for you in your daily work?
It's a great benefit. We can get a complete overview of the building. We can see all data points from room level to what the temperature delivered on the plant site from the chiller and the air handling units. And all this can be done remotely, so it saves a lot of money and time.
Okay. And we will now go in and look a little bit what has been learned in this project and how you have used the digitalization tools to find the real issue and so on. But of course, digital drawings and technical calculations that we have are one thing, but the reality is quite another sometimes. And there will always be some mismatches, of course. And as I have understood here, Anders and Robin, you have run into some issues with this system as well, of course. So we will look a little bit what could happen in the project, and it's not, some things are special and some things are a little bit more unusual. So Anders, take us a little bit through one of our special things that we encountered.
Yes, we ran into some different issues, and one of them was quite special. Some of the rooms, the corner office, were too cold in the winter season.
Okay, so what happened, and how did you notice this problem?
Yes, I noticed we got some angry mails from a property owner.
Yeah.
Yes, and the tenant of the office felt cold and complained to the property owner. The property owner complained and said that your room unit product did not work. This is a typical case when you cannot visualize the system, then often word stands against word. And the HVAC system is to blame for everything.
Okay. So how did you approach this problem in particular? And can you just tell us a little bit how the digital tools helped you?
Yes, it took a lot of time to find the real problem. But thanks to our digital tools, we could reduce the hours we spent to identify the problem in correct way. After going through all standard troubleshooting, we produced without identifying any faults, and we went back to look at the dimensions, the valves from the consultant, just to double check so no error was made in there. We checked the valves and noticed that were correct, and the room unit delivery, the capacity it was designed for.
So everything looked good?
Yes. So then we started searching outside the box to find what's causing the problem, and we decided to have a look at the building shell. We ran the thermal camera and showed us to the outer walls where Paul insulted not to build according to specification.
Okay, so here we can see in the picture when you actually took a photo of the wall and how the temperature was.
You can see it in the corner there. You can see in the picture the Paul inside the wall in this corner room caused and discomfort. But of course, to change the building was not the option due to aesthetic and cost and installation of radiators or additional units. It was an original suggestion from the property owner. Seemed unnecessary cost.
So how did you finally solve this?
We helped out finding a solution by adjusting the settings for the comfort modules in those rooms. We raised the temp set value and increased the airflow in the rooms. So now the comfort is within values, and we saved extra cost for the property owner, and we can also inform the tenant of the cause and what we've done to solve it.
That's great. This is very interesting, I think. How many hours would you have spent on this if you hadn't have the data and access to the system digitally? If you travel back in your career, Anders, 8 to 10 years, or Robin, 5 years ago, would you have been able to identify this and solve it?
Yeah, maybe, but it would take a long time with unhappy customers and a lot of extra costs.
Yes, and even if you have made adjustments which wouldn't help such, installing another unit to compensate, resulting only extra cost. So digitalization is important and effective tool in our daily work.
Great. And in this case, it was the cold bridges between the window and the walls that caused this problem.
Yes.
This is a real detective story, I think. So maybe this is a bit more uncommon, but at least we can identify it and help find the solution. But if we move on to another finding, which is in fact quite common, as I understand, and it's encountered when commissioning or after the commissioning, it's about the actuators on the water side. So can you tell us a little bit about that, Robin?
Yeah. We discovered that the several actuators on the water side was not properly mounted, resulting in water valves that couldn't close. So we discovered this as we saw the rooms were asking for cooling even in the middle of the winter.
Yeah.
And some of the rooms, the room temperature was very high, which of course was a result of the valve not being in control of the water flow.
So potentially a lot of energy waste and also annoyed tenants.
Yeah.
Yeah. So as I said, I heard from an unnamed source that this is a really common problem. How common is it?
Unfortunately, it's very common. So it's very important when commissioning the system to assure that the actuators is properly mounted.
So how would you have found this out in like a non-digital or analog system? And how has digitalization helped change your work and your process in this case?
Yeah, it would have been a bit more difficult, but if it had been an analog system, it would have been taking very time consuming, and it would not have been noticed until someone complained. Then we had to go out and manually check all units. The difference now is that we can make this check digitally and identify the problem from remote. So this saves time and money, and it's beneficial for the tenants and not disturbing them on site.
So it seems like you have fine-tuned a way to handle this effectively by using the digital tools and then spending less time manually checking. You can go to the correct unit and check it.
Yeah.
And as I have seen on sites, it's also quite complicated. And as you see on the pictures here, it's really hard to identify. And most often an inner ceiling is mounted already. So is it easy to reach all the units?
No, not always, unfortunately. That is something I think we need to think about in the future when we work more and more with DCV systems that contains a lot of moving parts. And we also have to make sure that the service engineers have access to be able to adjust, replace, and make sure everything works as intended.
Yes, and I can say that if they have an installer coordinator on site, the rule is very important. He or she needs to ensure the access to parts of the system during operation lifetime.
Great. Thanks for sharing these findings, Anders and Robin. And it is two great examples, I think, on how digitalization helps solving both comfort issues and energy issues. But I know that you have also been working a lot with the energy and the IQ aspect through optimization and also fine-tuning these functionalities that you presented earlier, Ulf. Sure. And that after the system has been running for a while. So if we first have a look at the air pressure optimization function, which we discussed earlier, in connection to energy savings. This is a standard feature in this particular DCV system. But to get this to work as intended in this particular building throughout the whole system, could you tell us a bit about that, Robin?
Of course. Depending how the system is designed, you need to calibrate the settings for the air pressure in the duct systems. And all the systems are different, just as people, and needs to be fine-tuned for the individual projects. If you don't follow up the operation of the air handling unit after a while, there's a risk that the systems will look at the top pictures. By fine-tuning the settings, you will get the system to work in an energy efficient way and always aim for the lowest possible pressure, like we can see on the low picture. And if you don't do this, you risk ending up without any pressure optimization most part of the year.
Okay, so it's a bit tricky, it seems. It must demand both experience and knowledge to manage this.
Yeah.
Or is it something that will be replace them with machine learning, or?
Maybe in the future.
But if we go back to managing this problem, can you talk us through the process that you used when and the digital tools that you used in fine-tuning this system?
Yeah. As I am located 400 kilometers from the site and connected to our digital systems, and elaborate with the settings from the experience from other systems. I make some changes and the system stabilized overnight, and then I could adjust a bit more, and then we found the optimal settings.
Great. So a combination of HVAC knowledge and experience in the service organization and access to digital tools, that will be key in the future, I guess, then. If we then move over to the hydraulic side, Anders, and we had this optimization on the changeover system with the temperatures. In this reference case, we are using a two-pipe system, as we mentioned earlier.
Yes, this is not a common application in Nordic at all. It's more common in the Central Europe. It has been working well in this project. However, that needs to be evaluated from project to project. What kind of building, layout, purpose of the building, etc.
So have you encountered any challenges with regards to this two-pipe system? We've heard from Robin that fine-tuning the air side and also comfort challenges in the building in some rooms, but on the hydronic side?
Yes, we have problem, and one problem we had that we could not foresee from the beginning was there was a function in the air handling unit connected to exercise fire dampers. This function triggered the system to change from cooling to heating, even if there was no real heating need. And then the system changed back to cooling again.
Okay.
This resulted the water tank changed from cool to warm, water without any real heating demand. Something that could have cost a lot of energy if we hadn't found it by monitoring the system.
So what has the new digital tools meant for you? Would you ever even have identified this?
Without digitalization monitoring of the system, we would never found this. But since we have a good overview of the system, both the room, plant level, we found the problem and altered settings preventing it from happening again.
Okay, so if you explain a little bit more your process and how you use your way of working through the digital system.
Yes, after the system was taken into use, we continuously monitor the log to see that all units were functioning in a good way. We could see that the chiller was changing operation mode from cooling to heating rather often in spring. Then we synced the logs from the chiller, air handling unit, shunt group, DCV system, and then we discovered that one of the standard function in the air handling unit was triggering the change of the tank. After identifying this, we were able to fine-tuning the system and get a better operation of the chiller.
So a conclusion here is that the fine-tuning of the system is important. Yes. And by using the digital tools and the historical analysis of the logs, you can also analyze the parameters and functions and save energy during the system's lifetime, but you can also prolong the unit's lifetime, I guess. And also ensure that we don't give any functionality that mismatch. Yeah. So thank you, Anders and Robin, for sharing all of this and how digitalization is working in practice, really. So we welcome back also Erik into the team here. And now that you have all, we have all here together, it's time to summarize this webinar. And what will it take, really, Ulf and Erik, to start with to get European building stock to zero emission buildings? Do one have to think completely new systems and completely new way of working, or what do you say?
Well, I think that, we can see from this project that even if you have high ambitions, which both we and the building owner had, it's really tough to meet today's target even.
Yeah.
And then to meet the targets of 2050 will be, of course, even more tough.
Mm.
So what I think is important, as we have said before, it's important to be, I don't think that we need to use these kind of systems, be early in the project, be able to select the right system for the right project, use the common tools that we have, maybe have a more advanced tool in the future as well. And also, I think that we need to be demand controlled all the way from the room products and all the way to the roof.
Thank you. And Erik's thoughts?
Yeah, I agree with Ulf, everything he said. And I believe that, for example, during the project planning, we need to involve everyone in a better way, clients and designers and suppliers. And also, I think that there will be needed more effort on the energy consumption and efficiency to find solutions that actually perform as intended also. And of course, products will need to be energy efficient. And as we have discussed today, also we need to back up with good data. And also, as we have talked about, I think that it's important that we visualize both indoor climate and also energy and energy performance more precise than what we generally do today. Yeah.
True.
Anything else, Ulf?
As Robin said, remote access, be able to find the problems and react quickly is super important. And I also think that, as I agree with you, that you need to have really, really good products. But it's when you make the products interact with each other, that is when you have the fantastic savings potential.
Yeah, true. Good conclusions. And it's very interesting topics in themselves, all of these, and could end up as a single webinar in itself, all of these parts. So we could say that partnering up really early is important, and for suppliers to give also consultants really good data and info about functions to create a good system is essential. And digitalization is key, both during design, operational phases.
Sure. Okay.
So now we will go over to the chat. I know that the time is almost up, and for you who has to leave, we say thank you for listening, and for you who want to stay and listen to the answers from the questions in the chat, we will continue for a couple of more minutes. Okay, so do we have any questions in the chat, Lars?
Yes, we have. You found them?
No, I can't see them here in my.
Okay, maybe, I don't know if the audience will hear, but I can read it maybe. From Adele, hello, thank you for a great presentation. You have mentioned oversizing some equipment, such as radiators and chill beams. Do you know the ratio of over-dimensioning or the extra cost of over-dimensioning compared to future energy savings, or are there other benefits?
Anyone who likes to answer that question?
I can answer. I mean, of course, there is an additional cost in that, but it's also a possibility to save a lot of energy. And when you look at it on a system view, you can also reduce the size of some products, the production units in the building. So all in all, I would say that it's not an additional cost that you have to, take in consideration. No.
Any comments to that, Erik?
Yeah, as for example, this project, we have used energy calculation and so on to try to find the design capacity and not use the traditional calculation methods, which generally end up in oversizing. So in this particular project, we have actually used the energy model in a better way. And I think that's something we have to be better even in the future to use these kind of calculations. Yeah.
Especially when you're working with demand control ventilation systems.
True. Good. Do we have more questions, Lars? I get a handover for the chat questions. Great. Anna has a question. Thanks for a great webinar. Questions to all. From your individual perspectives, how difficult is it to talk to investors, owners, and architects, engineers about investing in indoor environmental quality and creating the right indoor climate in Scandinavia?
Well, I would say that at least in Sweden and Scandinavia, when talking about newly produced buildings, the national requirements have pretty good standards. So if you follow the standard, which you of course have to do, then you will have pretty good indoor air quality. And then depending on the client, sometimes they want to have particular kinds of systems. For example, if they want to have airborne systems, then you have to work with that. But I would say for indoor air quality, if we talk about VOC and CO2, a correctly sized system have a good quality when it's new.
So very high level already with the parameters in the BBR.
Yeah, I would say so. Yeah.
And then the last question. We experience 4 to 5 years before the building owner to gets familiar with the installations. How long time did it take you to get familiar with this system? Maybe that is a question for Anders and Robin to answer.
I mean, I can say that since we are working with this project already, or continuously, so we are there. We have probably been looking in the digitalization tools this week.
Yeah.
So we are very well familiar with this project. But I also think that will be mandatory in the future because things change in a building all the time.
Yeah.
So to connect to your answer, I mean, if the building works from day one, doesn't mean that it's the same situation 3 years later. And if you don't have the digitalization, you don't know if you have a good climate, indoor environmental quality after 3 years. So that's the reason as well. I think that digitalization is important.
But the project has been up and running for
4 years. 3-4 years now.
Yeah.
3 to 4 years.
But you have grown with it like a baby, or
Yes.
More or less. More or less.
Okay, but the tools help you to get to know it better really quickly. Okay. And then we have a question from Maud Siron. Can the same principle be applied to hot and humid climate as we do in this system? For the climate beams and...
I mean, this is a dry system, so we are working with temperatures so that we should not get condensation indoors. And if it is a very hot climate and with humid air, then it will be trickier, I would say. Then you probably would need to have a wet solution. In some cases, I mean, it depends from project to project and climate to climate, I would say.
And also how good the building shell is.
Of course.
Yeah,
probably.
of course.
Erik, what are your comments?
I would say that as you talk about the building, you have to have the leakage for the building. The air leakage must be controlled, of course, so you don't have high air leakage. And as you said, if you have a more humid climate, you have to condensate the supply air more to have a little bit higher margin to the condensation temperature.
But also using sorption rotors.
Yeah, of course, that's another
beneficial.
important.
So it will save a lot of energy, but get comfort cooling anyway.
Yeah,
exactly.
Good. I think that was all of the questions in the chat. So we will go back to the presentation. And the conclusion and the summary was very good. And I would like to thank you all that has been participant in this webinar. And if there's any questions, you are welcome to contact the Swegon Academy, and we will transfer the further questions to the experts in this panel. So thank you for watching, and we hope that you will enroll to Swegon Academy's newsletter on our website, and also look out for next year's webinar series on these topics. Thank you.
Thank you.
Thank you.
Thank you.